Hello viewers and my dear students. Welcome to Problems on Analysis of Beams. Here I'll be showing you a demo on cantilever beam supported at one end and subjected to transverse loading at the other end using Ansys Release 14 of Mechanical APDL. The problem is this way. Please observe, the problem is this. That means a beam, this has 5 meter length. This is a cantilever beam supported at this end and loaded at this end, loaded at the free end. Okay, 10 kilonewtons, and it is 5 meter long. Okay, this is a cantilever beam. Okay, and the problem 2 clearly says beam subjected to transfer loading is as shown. Determine the following assuming beam has a rectangular cross section, 0.2 meter width and 0.3 meter depth. 0.2 into 0.3. 0.3 meters should be the depth. 0.2 should be the width. Assume E equal to 210 GPa. Poisson's ratio is 0.27. Find reaction at the supports, bending moment and shear force diagram using theoretical methods. Use Ansys Mechanical APDL to verify the above answers. This is a typical problem what you find in any university examinations and all that in the lab. See here, this I'll be doing in this way, in a simple way. See here, this is problem 2, the theoretical verification. This is a simple cantilever beam, 5 meter in length. You call this as fixed height as A, B. 10 kilonewton is this. Then reaction at A, since this is negative Y, okay, and positive A is 10 kilonewtons. That is RA is, the reaction at A will be 10 kilonewtons to support, to balance this load. Okay, reaction at A will be simple here, 10 kilonewtons or 10,000 newtons. Then shear force diagram, if you take any section plane here, to the right of it you observe. To the right of it, the downward force is 10 kilonewtons. Throughout this, to the right you find 10 kilonewtons or 10,000 newtons. If the force is downwards, we take it as negative. The shear force we take it as negative. If it is, the force is upwards, we take it as positive. Because why we have, you can always interchange the conventions and all that. This I have taken it because the same results you get it in Ansys also. Okay, that is why this is 10 kilonewtons. Any section plane here, imagine, to the right of it 10 kilonewtons. The downward force is always negative. Throughout AB, at the right you have 10 kilonewtons. In that way, it is 10,000 newtons is the shear force diagram. Throughout you write this way, AB minus 10,000 newtons. And also this, that is bending moment diagram, if you want to write, it is 10 into 5. Bending moment at B is 0. Bending moment at A is 10 into 5, 50 kilonewton meter. Okay, 50 kilonewton meter or 50,000 newton meter. Okay, this is the thing. What exactly is that? These things you will find out now first. That is reaction, shear force diagram, bending moment diagram and all that. This bending stress and all that we'll do in the next session. This I'll call it as session 1. Okay, session 1 on this problem 2, that is cantilever beam. Okay, now we'll go for the analysis using Ansys Mechanical APDL. I've already created one Gurdat beam problem 2. Okay, and also beam analysis for bending moment and shear force diagram. Okay, shear, that is bending stress diagram, we'll do it later on in the session 2. Okay, now we'll do it fast. See here, file, list log file also, if you see, there is nothing here, it's a new log file, and beam analysis, bending moment and shear force diagram, that I have created a new title, that's all. It is a fresh one which you can copy and paste for different analysis. Okay, now you see here, preferences, structural, okay, you say, preprocessor, element type, add, edit, delete, add, you say, beam 2 node 188 you take, beam 2 node 188 as we have taken in problem number 1, beam 2 node 188 you take, okay, you say, then you just say close. Beam 188 does not ask for real constant. Okay, I'll directly feed in sections. Then material properties you take. In the material properties, material models, structural, linear, elastic, isotropic. You see here what exactly they are given in the problem you see. In the problem it is 210 GPa, correct? No? 210 GPa, that is 210 GPa, okay. 210 GPa, 210 E9, okay. 209 E9 you take and 0.27 you take. This is 210 or 2.1 E11 or 210 E9 Newton per meter square. That means I have to compulsorily do the modeling in meter only. Okay, this you please understand. Okay, 210 E9 I have put or 2.1 E11. Okay, say material exit. There is only one material. Okay, then once you material, if you do it, then you go for section, beam, common section. Okay, common section, if you go here, breadth you take 0.2. Okay, breadth you take 0.2 and height you take 0.3. The beam, no, breadth is this, height is this. Okay, 0.2 and height is 0.3. You just say okay. Okay, that means automatically it would have calculated all relevant information. Okay, that is 0.2 and 0.3. Okay, which I have fed already. Okay, now what you do is, now we go for modeling, create key points in active coordinate system. Okay, one you create 0, 0, 0. Okay, then you say apply. Then you create 2. It is 5, 0. Okay, 5, 0 you create. Okay, then create lines, straight line, join this and this. It's a simple problem. Okay, no complications in model, at least here. This is the thing. Okay, now what I'll do is I'll do the meshing part now. Meshing, mesh attributes, no, default attributes, because there is only one material, one real constant. Okay, real constant I have put it in the section, only one material. In that way, just say meshing the default attributes. Okay, just say okay. Then come to size controls, manual size, lines, picked lines, pick this and say okay. And number of divisions you make 50 or 100. Let us say 50 divisions I'll make. Okay, just say okay. Okay, now once you do this, as you see here, there are 50 divisions are made. Then if I do mesh, lines, pick all or select this, say okay. Then if you go for list elements, okay, if you can observe here, 50 elements have been created. Okay, this can you see? This is elements, 50 elements have been created. That means whatever I've done, it is correct till now. Now it is better you save at this stage. That is, after meshing I've saved. In case I do somewhere in the that is solution phase, I can resume DB so that I'll come to this stage only. Okay, now I'll go for loading. Loads, define loads, apply structural displacement on key points. When if it is a cantilever beam, you arrest all degrees of freedom. All degrees of freedom you arrest here. Okay. Then force moment you take on key points. You take here. Say okay. Fy is, how much is that? It is minus 10,000 kilonewtons. Correct? No? Minus 10,000 kilonewtons. You just observe. Correct? No? Minus 10,000 kilonewtons. In that way, minus 10,000 kilonewtons, you just have to feed it here. Minus 10,000 kilonewtons, you feed it here in the negative y. This is correct. Okay. Now once you've done this, now solution phase, we are in the solution phase. The loading and all that is over. Solution, solve, current LS you do. Okay, current load step you do. Just say okay. Okay, you just have to wait for some time and solution is done. That means whatever we've done till now is okay. Okay, once you do this, then you go for general post process. Okay, here what you are interested here is reaction solution. Reaction solution, list results. Reaction solution, if you go, I've asked only reaction solution. It is only one. Okay, at node number 1, this is node number 1, it is Fy is 10,000, correct? No? Because you apply 10,000 here in negative and Fy is positive 10,000. In that way it is matching. This has to be recorded. That means in your record or even in the exam and all that, this result, node 1, in the direction of Fy, you have 10,000 positive. That means it is balancing the force which is being applied at this end in the negative direction. This is in the positive direction. This has to be recorded. Okay. Now this is one thing. Then what you do next is you go for element table. This is very important. Define table. Add. Okay. By sequence number. SMISC. 3 you do. Apply. Okay. By sequence number 16 you do. Apply. Okay. SMISC by sequence SMISC 6 you do. Apply. SMISC 19 you do. Okay. Then 3 and 16 will help you to get bending moment diagram. 6 and 19 will help us to get shear force diagram. Just say close. Okay. Now you carefully see. This is what I've told you in the first problem. Find reaction solution, bending moment diagram, shear force diagram. That's all I've asked. Okay. Plot results, line element results. 3 and 16. 3 and 16 will give you the bending moment diagram. You see, here it is almost negligible. Okay. And at this point, it is 49,500. Correct? No? But actually, you should get 50,000. 50,000 is a thing. But what I got is 49,500. Now, that is why I told you. Here, instead of 50 elements, if you had made 100 elements, it would have been almost equal to minus 50,000 only. Okay. Now it is minus 49,500, 500 less. My suggestion is, when you are doing, you divide this into 100 elements and see, and this will be almost equal to minus 50,000, and we are verifying the result properly. Then next you go for line element result. Okay. Before that I forget. This you compulsorily plot controls. Okay. Write meta files, invert white and black. In that way, this has to be recorded. This is a very important result. What you should actually get. Okay. This is one very important result. In the same way, line element result 6 and 16, 19 you take for getting the shear force diagram. This you get the shear force diagram. Okay. This is minus 10,000 throat. Okay. Did you follow? Okay. In that way, you have got all the results correct. Even this also, plot controls, write meta files, invert white and black. This also is stored. And for this problem, I got the reaction solution correctly, bending moment diagram correctly, shear force diagram also perfect it is. In that way, you got everything. Now you see here, now file, list log file operation also I'll tell you fast. Log file you take. I'll take the entire thing. Okay, entire thing. Control C I'll copy it. That is I copied. Okay. Now you see here, whatever, here start new. I'll just come out of this problem. I'll just say there is nothing in the problem. Okay. It is a fresh problem now. Okay. But now to get back the answers, what I've done already, what I'll do, I'll just copy it down, log file. Control V you do. Press enter. Whatever I have done till now, you are getting back the same results. Can you follow? See here, solution is done. Solution is done, and bending moments here. This bending moment diagram also, the shear force diagram also you got. In that way, even if you go for general post process, that is line element result and all that, even the shear force diagram also, that is bending moment diagram also you get. Everything you get. Thank you very much, viewing. Thank you very much, friends, for viewing. Thank you.